Oh, what'd you make it? Hashtag what? Calculator for Christmas. I like that. All right, guys, here we go. A lot of this is a review from the summer, but not everyone was here. Like the seniors weren't here. So now we're all together. And don't worry, I deleted the 30, 60, 90, and 45, 45, 90. So right now we're just going to do stuff that hopefully is a review. If you feel like I'm going too fast, let me know and I'll slow down. We're just doing right triangles. Vertex A creates little a, whatever opposite of angle A is at. Vertex B creates little b, and vertex C creates little c. And there's a very famous theorem. I already said the name of it. A squared plus b squared equals c squared. What theorem is that? Pythagorean theorem. There's also law of cosines that is a variation of this, but it's not for right triangles. I mean, I guess you could use it, but we're not there yet, so don't worry about it. So then there's this acronym that you've probably heard of, SOHCAHTOA. And that is made specifically so to help you. The S is for sine. This is how you spell it, S-I-N-E. And when you write it, you're going to write sine of something. So sine of some angle, theta, equals, and that O stands for opposite. So I'll go ahead and write what those words mean. And then the H stands for hypotenuse. So you're going to create hypotenuse. You're going to create a fraction. You're going to write opposite over hypotenuse. And that's what the OH stands for in the SOH stuff, the SO. That makes sense? And then let me go ahead and color code these. The CAH, the Ka. The C stands for cosine. That's how you spell it. And then the way you write it, you're going to say cosine of some angle equals adjacent over hypotenuse. The A stands for adjacent, which is just a fancy word for next door. Take it to the adjacent room. And the H stands for hypotenuse. The hypotenuse is always the longest side. Always longest side of a right triangle. Hypotenuse is a property of right triangles. So if you don't have a right triangle, you don't have a hypotenuse. Does that make sense, guys? Okay. And then the TOA, the T stands for tangent. And the way you write it, you go tan of some angle equals opposite over adjacent. I'm running out of real estate, so I just put OPP and ADJ. Okay. Nothing crazy, right? We haven't done anything yet. Okay, so here we go. I'm going to come back, and now I'm just choosing a neutral color. I'm just going to use black. It says sine of A, so I look at A, and it says, according to this, it says sine is opposite over hypotenuse. So what is opposite? Well, what's opposite that angle? Little a over, and the hypotenuse is always the longest side. The longest side is always the hypotenuse over C. Do you guys see what we did? What's up, Parrot?
Later on, those will be numbers, right?
Later on, those will be numbers. Cosine of angle A. Well, this says cosine is adjacent over hypotenuse. So what's adjacent to angle A? I'm looking up here. Well, at segment B. Yes, you can make a statement for why is C not the adjacent, because remember the C already has a name. That's called the hypotenuse. So I know it is next door, but that already has a name. It's the hypotenuse. Are we in the clear there, guys? All right, so it's going to be B over C. And then tangent. Tangent is opposite over adjacent. I'm looking at angle A, so tangent of A. I should be saying tangent of A, so I'm sorry. Put the A in parentheses like this. Textbooks have bad habits of not putting parentheses in your arguments. So tangent of A is A over B. And there it is. And that's it. Now, I know you're probably seeing these three and you're probably wondering, maybe you're wondering, or I don't know, maybe you're like, I just want to get through the day. This CSC stands for cosecant. Here's how you spell it. And it's just a reciprocal of sine. So what does it mean when you say reciprocal? Just means flips. Whatever was on the top goes to the bottom. Whatever's in the bottom goes to the top. So try not to say the word opposite, because opposite means it's positive, it's negative, it's positive. It's not that. It's just a reciprocal. So it's a reciprocal of which one? A sine. So I'm just going to do what with that A over C? Just flip it. So I'll write C over A. C over A. This SEC stands for secant, and it's a reciprocal of cosine. So what's the reciprocal of B over C? C over B. And then this one, everyone gets this one correct, because this one, you can tell it's in the name. That stands for cotangent, and it's the reciprocal of tangent. So what's the reciprocal of A over B? B over A. And there it is, guys. We just did our first ones. Cool or not cool? Yeah. Let's go to the angle B now. So sine B. So I'm going to go to B, and here I am. Let me change the color. Let me go to, I'll leave it as red. Let me go to red. So I'm looking at angle B, guys. So sine of B, opposite over hypotenuse. So I'm going to write this as B over C. Cosine of B, adjacent over hypotenuse. So I'm going to write this as, yeah, ask me. I'm looking at angle B, Eric. So see this angle B? Opposite, hypotenuse. And the cosine, see this, it says cosine right here. So cosine, what does it say? Adjacent over hypotenuse. So what's adjacent? This guy right here. I'll slow down. This thing almost choked me. All right. Why would it be what?
Why would it be?
Oh, because B is opposite from angle B. Yeah, you're referencing, you see, so make sure that we focus on the argument. So we're looking at angle B now. So you're referring angle B. Always reference angle B. So you got this. That's that leadership from the volleyball team. All right, tan B. So we're looking at angle B, guys. Opposite over adjacent. B over A. How do you feel? Not bad, right? Okay. All right, hook me up. What's cosecant of B? C over B. That's a reciprocal of sine. All right, parrot. What's the reciprocal of secant? I mean, what's secant B? It's a reciprocal of cosine. So I'm going to write what? Yeah, C over A. Good job. You got it. You got this, miss. Cotangent B. What is it, guys? A over B. How are we feeling? Not bad, right? Okay, let's keep going. All right, now we're just going to use them. So notice, let's pay attention to the argument. When I say argument, it's whatever's in parentheses there. That's what you call the argument. So this says sine A, so go to vertice A. And here we go. I'm going to put a little angle like that. Make sure you know what's the hypotenuse. My right angle aims at the hypotenuse. So that 13 is your hypotenuse. Hypotenuse. So label it first. All right, here we go. Sine. So let me write SOHCAHTOA. Bless you. I saw it coming. So I'm going to circle I'm going to underline the SOHCAHTOA, or the SOH. So that stands for opposite over hypotenuse. I'm looking at A. What's opposite? 5. What's hypotenuse? 13. There you go. I'm going to go to cosine. I'm going to underline cosine, CAH. So that means adjacent over hypotenuse. What's adjacent to angle A? 12. What's hypotenuse? 13. There you go. That's all it is. You're just using the definition. Tangent, TOA. What's opposite to angle A? What's adjacent? There you go. We just did it, guys. I'm going to change my colors. If you have a different colors, I'm going to go to angle C. So here's angle C in blue. Don't worry, I'll slow down. I'm slowing down. It says sine C. So again, sine says opposite over hypotenuse. What's opposite? 12 over, what's my hypotenuse? 13, there it is. Cosine C. So I go to C again, and I go cosine. Cosine is adjacent over hypotenuse. What's adjacent to angle C? 5. So 5 over 13. Perfect. See? And now the last one says TOA, tangent, so it's opposite over adjacent. So what am I going to write? 12 over 5. You got it. Good job, guys. All right, here we go. Let's go to number 2. Relax. Before you can solve this, you need to figure out what the hypotenuse is. This is the hypotenuse, the hippo. I'm going to put little y. Little y. I'm just doing Pythagorean theorem. 9 squared plus 12 squared equals y squared. It's a Pythagorean triplet if you recognize it, but if you don't recognize it, that's fine. Here we go. I'm going to go ahead and do the 9 squared plus 12 squared in my calculator. So I have a calculator right here on Desmos, so you don't need a physical one. I'm just going to type in 9 squared plus 12 squared, 9 squared plus 12 squared, and I got 225. So I'm going to write 225 equals y squared. But I don't want y squared, I just want y. So what do I got to do to get y by itself? Square root. So I'm going to square root, square root. So the square root of 225 is 15, but it's okay. If you didn't know that, you can just square root right here. And then just go 225. And then I put equal sign. And let me get that equal sign. There we go, 15. I'm not trying to insult your intelligence. I just want you guys to see, just in case, All right, so now I know that this is 15. I put 15 up here. All right, here we go. Sine W. So focus where the W is at. Sine is opposite over hypotenuse, so what am I going to write? 12 over 15, perfect. But before you continue, it does say up here in simplest form, so they want me to reduce it if it's possible. There's a number that goes into 12 and 15. Do you know what that number is? 3. 3 goes into 12 how many times? 4 times. 3, 6, 9, 12, 4 times. And 3 goes into 15? 5 times. 3 times 5 is 15. Do you see what we did there, guys? All right, let's go to cosine. Cosine is, I guess let me write SOHCAHTOA again. SOHCAHTOA to help us out. Once you're a beast, you no longer have to do this. Cosine, adjacent over hypotenuse. Adjacent, which is what? 9 over, and that reduces to, 3 goes into 9 how many times? 3, and 3 goes into 15? 5. There it is, 3/5. Last one, tan W. Tangent is opposite over adjacent. So opposite of that W is, not everyone at the same time, 12. And then adjacent, 9. So that reduces to 4 over 3. Good job, guys. See, it's not so bad. Don't worry, guys. We'll be done pretty quickly. Sine X. So I'm going to focus on X. So here we go. I'm focusing on X. And then opposite over hypotenuse, because that's what so is. Opposite over hypotenuse. So I'm going to write 9 over 15. And that reduces to what? 3 over 5. Cosine X. What's cosine X? 12 over 15. And that reduces to 12 over 5. Good job. What is tan X? 9 over, and that reduces to 3 over 4. There you go. Relax. I know. I remember last period, some of them exhaling with words. Relax. It's not that bad. So here we go. We're going to go slow. I'm going to put not to scale. In triangle ABC, the measure of angle C is 90 degrees. That's measure of angle C. Measure of angle. And then just say whatever letter you have there. Measure of angle C is 90. Segment CB is 3. Segment BA is 5. And segment AC is 4. Sometimes they put a little line on top to indicate it's a segment, a line segment. But they didn't this time. That's fine. What is the value of cosine of angle B? Okay, so I have a triangle. And this triangle is ABC. Here's my right angle. And I'm going to label that C. Because they told me that angle C is 90 degrees. Now it doesn't matter what you make A and what you make B. So I'm going to say A is right here, and I'm going to say B is right here. It's not to scale. They told me CB was 3, so I put CB 3. They told me BA was 5, so they told me BA 5. And they told me AC is 4, so I write 4. They say, what is the value of cosine of angle B? So that means this. cosine angle B. I write SOHCAHTOA. Once you're beast, you no longer have to write SOHCAHTOA if you know what you're doing. And I'm using cosine as adjacent over hypotenuse. And I'm referencing angle B. So here's angle B. And then all you're doing, guys, is just, and I'm not trying to insult your intelligence, I'm just referencing angle B. What is next door? Because it says adjacent. What's next door to angle B? The 3. So write 3, and then what's my hypotenuse? Fine, so there it is. So cosine of angle B is 3 over 5. Done. The hypotenuse is the longest side. This is a 5. Are we okay? All right, let's go to the next one. Same thing, guys. They told me the measure of angle C, so I'm going to write not to scale. Here's my right triangle. Here's my right angle. They told me angle C is 90 degrees. They told me that CB is 36, so I'm going to write A up here, B down here. So let's see, CB is 36, BA is 85, AC is 77. I haven't done anything. What is the value of the tangent of angle A to the nearest hundredths? Okay, so I'm going to write tan, angle A. I'm going to write SOHCAHTOA. SOHCAHTOA. I'm going to underline the TOA. And I'm just going to do tangent of angle A. So where's angle A? Up here. And I'm just doing opposite over adjacent. So what over what? Perfect. And I'm not even going to bother to try. I'm just going to put it in the calculator. It says nearest hundreds. So when it says nearest hundreds, that's 2 decimals. That's the second digit after the decimal. Two decimal and then digit. I hope I said it right. All right, here we go. Let me go to the calculator. I'm just going to go 36 over 77. 36 over 77. And I'm going to use 0.46 or 0.47. Which one am I going to use? 0.47. Thank you, Ms. Parrott. 0.47. By the way, have you ever heard of the word truncated? Okay. So when you guys have physics with Mr. Winters, and he does this question, or he'll do something similar because he's going to have to eventually use trig when he's doing forces of an inclined plane or forces at an angle. You're going to say, Mr. Winters, do you want 0.46? Do you want it truncated or rounded? Truncated means like the digit immediately. 0.46 would have been truncated. Rounded, because I have a 7 to the right, that's 0.47. Do you remember that, Eric? Yes, math life, science life. So remember that word, truncated and rounded. So what did we give them? We gave it to them rounded. All right, there we go. That's nearest hundredths. Are we okay, guys? Okay. This one right here, triangle QRS. The measure of angle S is 90, so I'm going to put not to scale. Let's see how nice they're being to us. Measure angle S. So this is the S. It doesn't matter the other 2 letters, so I'm going to put Q up here and R up here. So measure angle S is 90. Measure of angle Q is 61. So this right here is 61 degrees. And QR is 79. So this is 79 feet. By the way, you're going to do this in physics. Pretend that was a force. Some of the seniors have already done this, and I'm sure they remember some of this in physics. So there it is. And what do they want? Find the length of RS. So they want this length here in blue. Oh, I don't know how to do that. Yes, you do. Let's write SOHCAHTOA. And you can use Pythagorean theorem because you don't have the other side. If you had the missing side, you could have done it. So here's what you ask yourself: with respect to 61 degrees, is that line in blue, the SR or RS, is that opposite, adjacent, or hypotenuse with respect to 61? Opposite. What about the 79? Is it opposite, adjacent, or hypotenuse? Which one uses opposite and hypotenuse? Yeah, the first one, sine. So I'm going to write sine of 61 degrees equals opposite, SR. I don't know what that is. We're going to find it. Over hypotenuse, 79. Are we okay? Okay, what happened? You're the one that told me that this was opposite.
Correct. Why didn't you just put like an X variable?
I could put an X. Does that make you happier? Yeah, I could have put an X here. I just put SR to indicate the length of that. But this is like saying this is X. Would that make you happier? No, it doesn't. It doesn't.
I just didn't know that was perfect.
Yeah. Yeah, SR is like my missing variable. This is like an X. I did do it with an X in one of the periods. So if it makes you happier, guys, you can just do that if you want. See, it's the same thing. I'm gonna go ahead and leave it as the segment SR or RS. It doesn't matter. Okay, are we okay so far? All right. So right now I'm looking for segment RS. RS is being divided by 79. I want RS to get to. I want to get RS by itself. Right now, this is being divided by 79. RS divided by 79. What's the inverse operation of division? Multiply. So to get rid of that 79, I'm going to go times 79 times 79. Does that make sense? Okay, so I'm going to go times 79 times 79. Whatever you do to one side, you do to the other because of the equal sign. So now here's what I have. Whatever. See, I color code things, guys. 79 sine 61 degrees equals the segment RS. You're done. You just got to figure out what that segment RS is with a calculator. So I take my calculator. So here it is. I'm using Desmos. Okay. Before you do it, we're in degree mode, not radian mode. So you click on the little wrench. You see the little wrench where it says graph settings? And then the very bottom, you see where it says radians and degrees? You put degrees. Boop. You just degrees. So there it is. You don't have to do the sound effect. I've been watching a lot of that person that has lines and boops the nose. Do you guys know what I'm talking about? No? Okay. I'm going to introduce you to them. It's the best. I watch it every night before I go to sleep. Okay. Anyways, so here we go. I'm just going to type in 79 sine 61. So I'm going to go 79. Where it says functions, put functions, and you'll see them all. They're right there. Sine 61. And there's my answer. 69.0949. Is it coming out on both? Okay. 69.09. So what do they want? In feet, find the length of the nearest foot. Yep. RS equals 69 feet. How do we feel, guys? Okay. We're doing good. We're doing good timing. All right. So don't worry. We're almost done. We're almost done. Find the length in simplest radical form with a rational denominator. All right, this is a 45, 45, 90 triangle. This is more of like the stuff we did in the summer. Hey, don't worry, miss. We'll be fine. This is a property for the sides of a triangle. I have an x there, so maybe it's better if I do it in terms of x square root of 2. So what you're trying to do is get x by itself. This is my hypotenuse. So wherever you have 90 degrees is your hypotenuse. So that means x square root of 2 equals 1. Have I done anything crazy? Oh, because this is just a property of how my triangle reacts. So this is x, and then 1 is equal to x square root of 2. So I just made an expression. All right, here we go, guys. I want to get x by itself. So this is a product. This is x times square root of 2. So how do I get x by itself? No, not multiply because it's a product. Divide it. So divide by square root of 2, divide by square root of 2. X equals 1 over square root of 2. I'm okay with that answer. But it does say here rational denominator. So child, what does that mean? Rational denominator means no radicals in the denominator. That's what it means. So, I don't want you to be a robot. Remember your laws of exponents, square root of happy face times square root of happy face equals happy face. Remember that. So, all I'm doing, look, I have a square root of 2 in the bottom. So, I'm just multiplying by square root of 2 over square root of 2. Chop, why are you doing that? Guys, this is just 1. Anytime you multiply by 1, do you change the value? No, right? If you multiply anything by 1, the value doesn't change. 9 times 1, 9. 35 times 1, 35. Parrot times 1, parrot. Cool or not cool? So there you go. Well, child, but why did you do square root of 2 over square root of 2? Because square root of happy face and square root of happy face is just happy face. I just want it to be, I have a square root of 2 in there, so I have to use a square root of 2 in there just to get the 2 by itself. So here we go. Say it again. Well, because if you raise it to the power of 2, it's no longer the same value. Like 3 to the power of 2 is 9, so it's no longer 3. But if you multiply 3 by 1, it's still 3. I'm doing a different example. So we're multiplying it by 1 because we want the same value. You know what I mean? If we square it, it's no longer the same value. So 1 times square root of 2, square root of 2. Square root of 2 times square root of 2, 2. There it is. That's the same thing as the 1 in the top. Does that make sense, guys? Are we okay? We're almost done. Here's a question that maybe we might have to do a whole bunch of inverse operations. Bless you squared. That was almost synchronous. Bam, bam. All right. In Interstate 5 in California enters the San Joaquin Valley through a mountain pass called the Grapevine. The road descends from an elevation of 3,500 feet above the sea level to 700 feet above the sea level in a slant distance of 5.5 miles. Approximately what angle does the roadway make with the horizontal? Okay. They're being nice. They don't have to tell us that 1 mile is 5,280 feet. The first time I learned that, I was watching the movie Remember the Titans. Have you guys ever seen that movie? No? It's a football movie. And Denzel Washington tells Petey, who was his running back, he fumbles a football. And Denzel Washington goes up to Petey and he's like, how many feet are in a mile? And Petey's like, I don't know. And he screams like, how many feet are in a mile? Like, I don't know, coach. Then he goes, 5,280. And you run every one of them, Petey. And he makes them run that. Yeah, okay, that's it. That's how I learned how many feet are in a mile, guys. You should know a few. Like, do you know how many centimeters are in an inch? No, not even close. That's a foot. 12 inches in a foot. In 1 inch, there's 2.54 centimeters. There's just little random things that we should know, right? We should definitely know the metric system, right? Kilo, hecto, deca, base, decicentimill. We should definitely know that, but we'll talk about that when the time comes. Okay, sorry guys, let's come back. Here we go. So at a moment, I am 3,500 feet above sea level, and then there's a road. This road is going down, so I'm just going to go ahead and I'm going to draw. Here's my vertical line for that moment. Here's sea level, and I'm going down. And at another moment in time, I am only 700 feet above sea level. So this is my horizontal there, 700 feet. See, this is a road. How long is this road? 5.5 miles, not to scale. So at this moment, I'm 3,500 feet. At this moment, I'm 700 feet. Way down here. They want to know approximately what angle does the roadway make with the horizontal. So they're talking about this angle right here. That's just a theta. Relax. It's like a variable. That's just a variable. We haven't done anything crazy. All right. So before I do this question, guys, I need to figure out, I'm going to use burnt orange if we have any longhorns in here. I'm going to figure out what this distance is right here in burnt orange. Yeah. I was 3,500 above sea level. And then I went 5.5 miles down, and now I'm only 700 feet above sea level. So what is this segment here in burnt orange? What? Don't be dead. This up here I was 1,500. Now I'm at 700. What is this gap? What is this vertical? What is this vertical?
It's gonna be 2,800.
Yeah. How'd you get 2,800, Miss Parrot? So Miss Parrot said, well, that was 3,500 and that was 700. This has to be 2,800 feet. See, you're not dead. We got this. All I did was subtract. So that's how much feet you go down in 5.5 miles. I need to turn miles into feet. So take your calculator, take your Desmos. So let me go back to Desmos, and I'm going to go 5.5 times 5,280. And I got 29,040 feet. 29,040 feet. Okay? We're almost done. With respect to theta, is the 2,800 feet opposite, adjacent, or hypotenuse? What about the 29,040? Which one uses opposite and hypotenuse? Yeah, let me write the SOHCAHTOA there. Yeah, sine, opposite and hypotenuse. Do you guys see that? So here we go. I'm going to write sine theta equals 2,800 over 29,040. So here's something that maybe we know, maybe we don't know. We're about to find out right now. How do I get theta by itself? It starts with an I. Second letter N. I guess you could also say A. Inverse, the inverse sign. So here we go. To get theta by itself, you have to do the inverse, guys. So theta equals inverse sign, or you can say arc sine if you don't like the word inverse. Inverse sign, to put a -1 of 2,800 over 29,040. If we have issues with inverse, maybe we'll have to do a lesson on inverses. And there it is, guys. Type that into your calculator. So here's my calculator. Make sure that you're in degree mode. I'm already in degree mode because I did it earlier. And I'm going to push functions, and I look for inverse sine. There it is. Inverse trig functions. Inverse sine. And I just put the numbers. What was it? 2,800 over 29,040. 2,800 divided by, I already forgot, 29,040. Thank you, miss. And there it is. It's supposed to be a small number because if it's too steep, it's going to be bad. 5.533 degrees. If they don't tell you how many digits after the decimal, always put 3. I already forgot it. 533. Got it. 5.533. 533. Put the degree symbol. Because if you don't put the degree symbol, it's going to be a radian. How are we feeling? Okay.
So,
Yeah, hit me. Hit me, parrot.
that's basically just a hypothetical angle that was created to do the little star.
Yeah. That is the angle. And when you're an engineer and you figure out stuff like that, there's like tolerances. You can't be steeper than certain angles and stuff. All right, guys. So what you're going to see today in Delta, in a little bit when you create your accounts, you're going to be seeing things like this. They're not that bad. They really aren't. It says, look at this one. Which segment is adjacent to angle N? As a matter of fact, and I think these are even multiple choice. So here's my right angle. So which segment is adjacent to angle N? Yeah, MN. That's it. MN. Maybe there's a little line on the top. Maybe you say NM instead of MN. Whatever. That was it. Was that easy? Yeah, see? Find the value of sine K rounded to the nearest hundreds. Okay, here's K. Before I do anything, I need to do Pythagorean theorem. So I'm going to put little j here. I'm going to go 10 squared plus 24 squared equals j squared. If you recognize this as one of the special ones, go ahead and just put it in. I think it's 26, but if you don't recognize that, then don't worry about it. To get it by itself, I don't want j squared, I just want j. So to get j by itself, you just take the square root. 10 squared plus 24 squared equals j. So that's exactly what I'm going to type in to get my j. So I'm going to go to Desmos, and I'm going to go, let me clear everything. I'm going to go square root 10 squared plus, what was it? What did I say? 24 squared? 24 squared, and then there it is, 26. So little j is 26. So now that I know the little j is 26, I'm going to write SOHCAHTOA. And all you're doing is trig ratios. So here we go. Find the value of sine k rounded to the nearest hundreds if necessary. So sine k equals, what's opposite angle k here? 24. And then what's my hypotenuse? 26. I know you can reduce it. Don't. They want it to the nearest hundreds. Just take your calculator. So here's my Desmos. Come on, Desmos, where are you at? Well, let me just reduce it. All right, and then right here, I'm just going to go 24 over 26. And there it is. They said nearest 100, so 0.92. 0.92. 0.92. How do you feel, guys? All right, so let's go ahead and create our accounts. Let me stop this Zoom here.